So I want to introduce our next speaker, Marta Rivera. She is the lead scientist, a data scientist at Clarity.ai. She's a physicist with a PhD in computational neuroscience by training and a data scientist by trade. So I'm going to stop sharing, Marta, and whenever you're ready, you can begin.
So my name is Marta Rivera, and as Alexandra mentioned, I'm one of the data scientists at Clarity AI. And my talk today is like a very short version on what I will talk about on October. But instead of focusing on the whole architecture organization in our data pipelines, I'm actually gonna talk about some specific things that we do to be able to integrate non-developers into our data flow development. Okay? How we integrate the knowledge and how we let everybody in the team participate, even though they cannot write the Python code directly. Okay, so first of all, full disclosure, who am I? I am not a developer. And as Alexandra mentioned, I'm a physicist with a PhD in computational neuroscience, and I write code every day, but I'm not really a developer. I'm not a computational scientist or an informatics engineer or anything like that. So all the things that you see here are actually places where I worked on before, and all the images are actually part of my research in a previous life when I was actually a neuroscientist. And this is all, or is this organized on purpose? People like to think on their career as a clear path, clear straight line where everything builds together, one thing after the other. That's definitely not my case. I have the feeling that things are happening to me kind of randomly, and that's okay. And so basically, when I studied physics, I didn't know I was going to become a computational neuroscientist. I didn't know I was going to work in the US and in Portugal, but it's what I did at the end. And like 3 years and a half ago, when I decided to leave academia and start working in companies and then start working on the financial sector, I had no knowledge about it at the beginning. So I was definitely not getting ready and building up my career towards that. And this is my food for thought for all the younger people out there. So it seems like everything is organized and like all the careers are in a straight line, but if you are taking detours, that's also fine, because basically I'm in a very great place now, but I didn't anticipate at the beginning. So this is just who I am at this point, so you can understand better what I mean. So
Marta, I'm sorry to interrupt. Some people cannot hear you very well, so I'm not sure.
I can, but because it's cutting down or because I'm not loud enough?
It's cutting out a little bit. I'm not sure if your bandwidth is, or if it's us on this
my
side.
one with, yeah, let me reset my internet connection just in case, okay?
Okay. We'll give Marta a couple of seconds to fix her audio and her video.
Okay, can you hear me now better?
I can hear you very well. If anybody is having sound issues, please just write me a message.
Better now, guys?
Good,
okay.
Marta.
Cool, let's keep going. So what I want to talk to you about is the specific data pipelines that we build. What do I mean with that? So in Clarity AI, we dedicate our time to compute complex scores about the sustainability of companies, okay? We measure how sustainable companies are, so our clients, that are actually investors, can make better decisions and align their portfolios and their investment decisions with their ethical principles or the ethical principles of their clients. So we developed at least 10 of these guys lately, and they are very different to each other, and the common thing, the thing that they have all in common, in that they start with a research idea. Okay, somebody in the research team or in the data team, data science team, have a crazy idea about how to compute something new, and we actually put the whole idea together until we write the code that automatically computes all those crazy ideas that we had at the beginning. So in the ideal world, as the way we like to think about it, is this pathway, right? You start with, there was a product need, either because of the sales team have a new requirement from clients, or because we have explored the market and we think there is a new opportunity for new things to be measured, for new things to be developed. We start researching all the possible solutions that we can think on. We compile all the data necessary to do that heavy computation. We implement it, and then we monitor it as we get updates and things like that. Okay, this is the ideal world, as everybody would like to have their products being developed, their data products being developed in this case. But this is a bit closer to the real world, okay? This is way messier than one would expect. For example, you have an iteration, you research your solution, and then you realize that you were not entirely sure what you wanted to measure. Then you compile the data, there is data missing. So you start building machine learning models to infer part of the data. That increases the complexity a lot. You start adding validation steps all across the pipeline to make sure that everything that is being computed makes sense, and is in line with the product requirement that you have at the beginning. And all these arrows that you see here are actually communications, okay? Every time that you have a data compilation issue and you go back to product requirement, you have a communication across teams. So you have people that don't understand exactly what you are putting together, but ask you to put that together. And it's one of the things that I'm going to emphasize here a lot, that when you are developing complex data pipelines, and these ones, you really, really have to think on how others will see what you are doing. And communication is key and essential for all these process and these projects. Okay, and I'm pretty sure many of you already have experiences working on across departments. But this is our daily life. This is how we put this data pipeline together and all the iterations that we find. Because we are finding all these iterations, but we still have to deliver fast and in time. We are trying to make all the coding very efficient and very close to the actual user. Very close to the actual user, very close to the data itself. Okay, and that is the reason why we use the tools that we use. So to be able to be compliant with these actual schematics of how the data pipeline development is, we believe that we have these requirements. We need our process to be traceable and reproducible. Okay, every time that we run something, we have to make sure that we know where the things are coming from, that every data source is traceable, and that we can reproduce every single line of code, that there are no random states or random surprises because we were using a data set that doesn't exist anymore and we didn't keep it, or I just made this manual calculation in a piece of paper and I just wrote this number here. So avoiding hard coding is also good, and things like that. We also have to live in a continuous integration world. Why? Well, because all those arrows with iterations means that sometimes you have to rewrite the code. Why? Well, because you have an hypothesis about how the data was organized and it turns out that was not entirely true. So you have to rethink that and restart the calculation itself, or you didn't have enough coverage as you thought you had. So this continuous integration is going to drive one of the fundamental things that we do, that I will show you in a second, that is the orchestration of microservices. Exactly for that. Okay. We need to be also very flexible. That's another one. And this is in relation with that continuous integration. We need to be able to change every piece at any time. And that sounds like a bit of a nightmare, mostly for people with micromanagers or that need to have everything under control. So sometimes you have to let it go and live with the fact that everything can change at any minute because the teams are large and the data flows are fast. So sometimes you just need to be very flexible. Communication is key. As I mentioned before, you have to be able to coordinate across very different teams. And of course, the transparency. If you see something weird, you have to say it out loud, even if that means repeating some part of your code, or needing to repeat an analysis, or needing to relook or look for extra data sets. Okay, that transparency is very important, so to make everything move forward. And to fulfill all the requirements, these are the tools that I use. Some of them are maybe familiar to use. We use some more, but these are the fundamental ones that I want to talk to you about today. So we use GitLab, of course, to have our code version. We use Amazon Web Services to keep all our data. You could use any other platform, but this is ones we use. I'm not saying these are the best. These are just the ones that are working for us for the specific purpose that I'm mentioning today. We Dockerize our data set. We use Papermill. That is something I would talk to you about. That is we found very useful to live in that flexibility, continuous integration phase. We use Jupyter notebooks and Bokeh. And if you don't know what Bokeh is, basically it's just it's a Python library that allows you to generate interactive plots. Okay, that is extremely useful. And I didn't mention Airflow. We orchestrate the whole thing with Airflow that allows us to keep that reproducibility. Okay, so let's go step by step. So Airflow, we use Airflow, as I mentioned, to orchestrate microservices. These microservices allows us to be flexible and to keep that continuous integration idea. Why I believe this is so important, and I really believe this is very important. Well, every time that you see one of those little boxes, and I erase the labels because they were not interesting to you, but this is an actual Airflow schematics that we have in production right now. The key here is like every time that you propose a new methodological change because you want to upgrade to version 2 of your methodology, for example, you can identify right away which box you have to change. And the key thing about the microservices and keeping the contracts between boxes very clear is that you will only change that box, okay? Having a static piece of code can be useful for many other things, and I know many people hate microservices for very many reasons, but for us, they really make the work. Because, as I mentioned, you just need to change that little box, and you know that as long as you keep the contract clear, you keep sending the information with the same format to the next box, you will be fine. Okay, so the orchestration with Airflow allows us for reproducibility because we can run the same code over and over and keep the versioning of that. And the microservices allows us to increase that flexibility and that continuous integration that we find so useful. Okay, so but what is inside each of those boxes? So here I have an example of 3 of those boxes. Okay. Each of the columns here will be one of those boxes, this one, and that one of the green boxes that we had before. And this is again orchestrated with Airflow. So what we have here, each of these columns here is a GitLab repo, okay? That is Dockerized, and Dockerized allows us to always run the same code with the same requirements, and that's in the same environment, and that's very important, the versioning of, as you know very well, the versioning of your functions that is guaranteed by Docker. And we use this set of parameters and notebooks into the Papermill. What is Papermill? Well, Papermill allows us to run the Jupyter notebooks as if they were code. Okay, why Jupyter notebooks? So Jupyter notebooks, I hope everybody knows, is a combination of codes and figures just in the same page. That is extremely useful for analysis because you run a line of code and just underneath you have the plot. Okay, so you have the code, the text, the comments, the analysis, everything together. When you are communicating with other people and you are very close to the research team as we are, you really need to make that clear for everybody, how the code is behaving and what every single line of code is doing. So just in case somebody else can go and refresh. So when we use Papermill, basically we allowed non-developers to see what we are doing right away. And they can actually explore the notebook and help you with the debugging many times, okay? Can go see the notebook. And this also allows us to skip one iteration in the production system, right? Because we use the same code or almost the same notebook that we used to do our checks. We can put it in production right away. Okay, so we don't need to, okay, this is the pilot, then we set up all the classes, I generate all my final code. That's something that we do afterwards, okay? Of course, we refactor all our code afterwards, but we have a running version with almost analysis code right away. And that's why we find Papermill so useful for us, okay? Papermill is very easy to use. It just has 3 parameters, the inputs, where you want to save the outputs, and the notebook, that Jupyter notebook that you have, that you want to run, okay? And I mentioned these are all different GitLab repos, Dockerized, and extremely useful for us. So when are the non-developers interacting with all these things? I already mentioned a couple of them, but I missed the final step that I think that is very important, that is this continuous monitoring. Okay, apart of having our Jupyter notebooks that the non-developers can actually open and see, we go one step forward and we plot all our results in Bokeh. Okay, we generate this. Bokeh also is not only the functions, the plotting functions themselves. It also actually have some what is called Bokeh servers that allows you to deploy, okay, your application with all your plots. We have also used Plotly. It's not that Bokeh is the best in the world. Plotly is actually prettier, but they are different. They are dashed by Plotly or Bokeh, or there are different options. We have used several of them. I'm just plotting Bokeh here because it's the last one we have used. So how are the non-developers interacting with all of this? Well, at different phases, okay? All the pencils here means that they can actually edit things. And the eyes means that they can visualize. Okay, so most of them cannot actually run the notebooks, but they can visualize the results on the notebooks, and that helps for the debugging, mostly for the weird data cases or edge cases that you missed as a developer when you are or a data scientist where you are writing the code. And in the Bokeh, they can visualize the results, but because they are interactive, and that's what this pencil means, not more than that, they can actually select which part they want to see and generate new combination of plots. Depends on how you build the Bokeh server. New generation of plots to actually analyze and keep going through the monitoring phase and all the validation with their own expertise and the idea that they have. But I think the most interesting part here is these pencils have here when we are talking about editing the parameters. So basically, we are allowing non-developers or everybody in the research team, for example, to edit either YAML or Excel files that we convert into JSONs, for example, and to change specific parameters and to add new entries and to generate small formulas also that will go directly as parameters into the code. Okay, so you have to be careful and be smart to write the input parameters in a way that somebody else can edit it. And basically they are changing what is being computing just by changing the YAML file by themselves, okay? They change the YAML file and say, okay, I'm adding this new metric, for example, that has this new specification. I want this new metric to be run only for countries operating in these, so for companies operating in these countries with these business lines, okay? We have an agreement, and that also is including all the communication process. We have an agreement on what you can change and what are the standard and the parameters that you find, and actually find the YAML way more useful than the Excel, because they are more used to Excel and they tend to write random stuff there, but in the YAML, because it's so foreign for them, it's very clear for them then that the machine is going to read that automatically, so they tend to be more strict about what they write in the YAML, and that's how they interact with the code. They tell me, okay, I have a new configuration file. We load it, and the new data that is being generated is the methodology that they wanted to implement. You can even add small formulas and things like that. So they actually interact with the methodology right away without writing the code themselves. Okay, we found that extremely useful. So that's what I wanted to tell you. These are my take-home messages, that implementing complex data pipeline requires many iterations, many more than you may expect it, across all levels involved, across a company or the team. That the key requirements here are traceability, continuous integration, flexibility, communication, and transparency. It's very important to be open and transparent. We find that the best combination of tools is to develop orchestrated microservices with notebooks, and that the internal interactive dashboards with Bokeh are way more flexible than static reports. Okay, and actually all the things that I have told you today are implemented by some of these people here in the data science team, and we have some position open at Clarity, so please go ahead and join us. Thank you.
Thank you so much, Marta. I'm going to let everybody start writing questions on the chat if they have any, and I'm also going to unmute all of the participants in case you want to ask a question live. So now everybody is unmuted. If you have a question, please feel free to send it out on the chat or on the or just voice it out. Now's your chance. I have one question in the meantime, Marta. I mentioned earlier that I'm not a programmer or developer. So I just wanted to know how important you think it is for non-developers to have programming experience.
So in our case, it actually helps us a little bit when they have some programming experience, because it also helps them to be in your shoes. But it's also helpful for us to have some analytic experience, some research experience. So the more you know about other people's work, the easier it is to actually communicate and to understand that if you randomly change and instead of writing 0.2, you start writing 0.2, then that can be terrible for everybody else behind the scenes, even if it's the same number for you. Okay, so when you have some programming skills, it also, in our case, it allows us to share the notebooks easily because they can write the code much better. But I mean, it's just a matter of them learning the tools with time, and we are all getting better and better at communicating and realizing those things. For us, at the beginning, for me, it was a mystery why people would use Excel instead of Python to compute anything, and it's still a mystery to me. And they seem like impossible to parse, but it's a great tool. So you have to be in other people's shoes, I guess.
Is there a basic training that you would recommend for people?
So, I mean, in our case, like we are using Python, there are millions of courses out there. They are even for free. I have my preferred books that I use to learn, but basically and the resources are infinitive. And I mean, I could collect and share with you afterwards some of them, but literally you can have data camps are actually quite useful. Many people use them and get to learn a lot with them. But there are even courses in YouTube that you can use.
Okay, we have a question here. It says, "Do you use Binder?" Binder. Don't even know if I'm pronouncing it right.
Me neither. I'm not. I'm not very familiar with Binder, so I haven't used it before. But I will check it out. If you think about it when you saw my talk, maybe it's useful for us. And I got also, Manuel is also asking why I don't use test log to monitor the pipeline. Well, that's a very good question. Tests and logs are hard to write, and we write them in the second phase when we do the refactor and we actually transform everything in automatic code. We set up all the proper Python tests and all the proper logging. At first, we let humans to be our testers and our loggers. That's why we add so many check-in phases and so many eyes across the process. So yeah, we do it in the refactor, and I acknowledge how important they are. But when you are so close to the code and to the data, I mean, I would say you normally don't need them. But of course, when everything becomes automatic and you don't interact with the code so much every day, then of course, you should use them.
Okay. I think that's all the questions that we have for now, but people can still feel free to write them in on the chat. I think we also have time for another quiz. Manuela, can we launch that?
Yes, I'm going to launch the poll right now. And it is up.
Okay. So we've got two questions here. The first one is, which file formats are recommended for non-developers to interact with the code? And your options are none, stick to what you know, non-developers. 2, PDF, PowerPoint, or Doc, and then YAML and Excel. We already got some questions, some people answering. And then the second survey or second question is, which tool can you use to run Jupyter notebooks automatically? A, Amazon Web Services, B, Papermill, and 3, GitLab or Bokeh. We've got 14 replies so far, 15. Okay, guys, you have 50 seconds. I think we can give another 10 seconds. Should we count down?
Ooh, let's do that. I love countdowns.
All right, go for it, Manuela.
10, 9, 8, 7, 6, 25 of 36 people. There are 10 people, 11 people missing. 5, 4, 3, 2, 1. Sorry, I got really excited with that. All right. Should I share the results?
Yeah, please do. And Marta, you want to walk us through the right answers?
Sure. So the first one was about the file format. I will never say to non-developers to stick what they do. I would love for everybody to write code. I think it's the best tool out there. So please do it. And I will recommend YAML on Excel. Yeah. We transform the Excels into JSON. And as I mentioned, I prefer YAML because it's foreign to many other people. So they stick to the machine, to realizing that the machine is going to read it automatically. So they do less crazy things sometimes. They create creative with the Excel sometimes. And so congratulations, you got it right, most of you. And the second one is the tool to run Jupyter notebooks automatically without the manual interaction of the shift enter or whatever. And of course, it's Papermill. You need GitLab. I mean, you can use GitLab to keep your notebooks, but of course, the way to run them is Papermill. So good job, guys. Congratulations.